this lecture, I am going to present what is rigid jointed space frame and what is static indeterminacy and how to determine the static indeterminacy of rigid jointed space frame by two approaches. Then I would like to solve some problems how to determine the static indeterminacy of rigid jointed space frame. Coming to the rigid jointed space frame, first we have to know what is skeletal structures. The skeletal structures are those structures which can be idealized to a series of straight or curved lines. This is a one-dimensional structures. The skeletal structures can be further classified into two types. One is pin jointed frames and the second one is rigid jointed frames. So what is pin jointed frames? So in pin jointed frames, the members are connected by means of pin joints. Then what is rigid jointed frames? So in rigid jointed frames, the members are assumed to be rigidly connected and the angle between the members meeting at a joint remains unchanged. The skeletal structures may also be classified as a plane frame and a space frame. So in plane frame, all members of the plane frame as well as external loads are assumed to be in one plane. In the case of space frames, all the members of the frame do not lie in one plane. The member of a space frames are subjected to axial force only if the joints are pin connected. On the other hand, if the space frames are rigid jointed, it is known as rigid jointed space frame. The member of this type of frame are subjected to axial force, shear force, bending moment and twisting moment. The joints of the rigid jointed space frames are assumed to be rigid so that the angles between the members meeting at the joint remain unchanged. The space frames are formed by combining a series of plane frames. These are the different examples of the rigid jointed space frames. Then coming to the static indeterminacy of rigid jointed space frame. First we have to know what is statically indeterminate structures. The statically indeterminate structures are those structures which cannot be analyzed with the help of equation of static equilibrium alone. In the case of statically indeterminate structure, the number of unknown is greater than the number of independent equations derived from the condition of static equilibrium. Hence, the additional equations required based on the compatibility of deformation for the determination of all the unknowns. The number of these additional equations necessary for the solution of the problem is known as the degree of static indeterminacy or degree of redundancy of the structure. Or the number of equation of equilibrium falls shorter than the number of unknown direction components is known as the degree of static indeterminacy or degree of redundancy. The static indeterminacy of rigid jointed space frames can be determined by two approaches. Coming to the first approach, in this approach the total degree of static indeterminacy is equal to the sum of degree of external and internal indeterminacies. So the degree of static external indeterminacy DSC, that can be denoted by D in subscript SC, and the degree of static internal indeterminacy capital D and the subscript SI. And the total degree of static indeterminacy can be determined using this equation: ds is equal to dsc plus dsi. The total degree of static indeterminacy is equal to degree of static external indeterminacy plus degree of static internal indeterminacy. The degree of static external indeterminacy for space structure can be find out using this equation. DSC is equal to R minus 6, and the degree of static internal indeterminacy for a rigid jointed space frame, that is DSI, can be determined using this expression, using this equation. DSI is equal to 6G. In the case of space structure, there are 6 reaction components are released, that is 3 forces and 3 couples. So the expression DSI is equal to 6C, where C is the number of cores. So after getting the DSC and DSI, then you can find out what is the degree of static indeterminacy of the structure. So DSC is equal to DSC plus DSI. Also, the degree of static indeterminacy of rigid jointed space frame can be determined using the alternative approach. In the case of rigid jointed space frame, each member carries 6 unknown internal forces, 3 forces and 3 couples. The total number of external reaction is equal to R, and the total number of unknown forces is equal to 6M plus R. And the condition of static equilibrium provides 6 equations at each of J joints. So the total number of independent equations equal to 6 into J. Then the degree of static indeterminacy of rigid jointed space frame can be determined by using this equation, that is ds is equal to the total number of unknown minus the total number of independent equations. So ds is equal to 6m plus r minus 6j. 6m plus r is equal to the total number of unknown forces, and 6j equal to the total number of independent equations. So ds is equal to 6m plus r minus 6j, where m is the number of members, r is equal to number of reaction components, and j is equal to number of joints. Then coming to some examples. Then coming to the first example, determine the degree of static indeterminacy of the space frame. So this is the space frame. These are the supports. All the supports are fixed support. These are the vertical members, and these are the horizontal members, and these are the joints. By using this equation, determine the degree of static indeterminacy of rigid jointed space frame. That is ds is equal to 6m plus r minus 6j. Here m is equal to number of members, r is the total number of unknown reaction components, and j is the number of joints. Count the number of members. Number of members m is equal to 1, 2, 3, 4, 5, 6, 7, 8. M is equal to 8. Then count the number of reaction components. At each fixed support, there are 6 reaction components. Here 1, 2, 3, 4. 4 supports, so that total number of reaction components equal to 4 into 6 is equal to 24. Then count the number of joints. Here the joints are 1, 2, 3, 4, 5, 6, 7, 8. The joint j is equal to 8. Then by using these values m, r and j in this expression, and find out what is the degree of static indeterminacy. So ds is equal to 6m plus r minus 6j. 6 into 8 plus 24 minus 6 into 8 is equal to 48 plus 24 minus 48 is equal to 24. So this is the degree of static indeterminacy of this space frame. The degree of static indeterminacy of this frame also you can find out using the alternative approach. So here you have to find out what is the degree of static external indeterminacy and what is the degree of static internal indeterminacy. So the external indeterminacy you can find out from the support condition. So here there are 4 supports, and at each support there are 6 reaction components. So the degree of static external indeterminacy is equal to DSE is equal to R minus 6. So DSE is equal to 24 minus 6 is equal to 18. Then find out the degree of static internal indeterminacy. So the degree of static internal indeterminacy DSI can be find out using this expression. DSI is equal to 6 into C, where C is the number of chords. So in this frame, so here one chord is required to make the structure open configuration. So C is the number of chords required to make the structure open configuration. Here C is equal to 1. Then the degree of static internal indeterminacy can be find out using this equation. DSI is equal to 6 into 1, that is equal to 6. Then after getting the DSI and DSC, then you can find out what is the degree of static indeterminacy. So the degree of static indeterminacy is equal to the degree of static external indeterminacy plus degree of static internal indeterminacy. So this is equal to 18 plus 6 is equal to 24. So here also you got 24, and in the alternative approach also you got 24. Then coming to the second example, determine the degree of static indeterminacy of the space frame. Here this is a two-base space frame. So these are the supports. So at each support there are 6 reaction components. So here there are 6 supports. So 6 into 6, that is equal to 36. The number of total number of reaction components is equal to 6 into 6, that is equal to 36. And these are the vertical members and these are the horizontal members. Then count the total number of members. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the number of members equal to 13. Then count the number of joints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The number of joints are equal to 12. Then put the value of MRJ in this expression. The degree of static indeterminacy of rigid jointed space frame is equal to ds is equal to 6m plus r minus 6j. So here you put m, r and j, then you can find out what is the degree of static indeterminacy. So ds is equal to 6m plus r minus 6j, that is equal to 6 into 13 plus 36 minus 6 into 12 is equal to 78 plus 36 minus 72 is equal to 42. So the degree of static indeterminacy of this frame is 42. And also you can find out using the alternative approach. So in alternative approach you have to find out what is the degree of static external indeterminacy and what is the static internal indeterminacy. So the degree of static external indeterminacy can be find out from the support reaction, from the support condition. So here there are 6 supports and all the supports are fixed, and at each support there are 6 reaction components. So the total number of reactions are equal to 36. R is equal to 36, and by using this equation DSE is equal to R minus 6, so you can find out what is the degree of static external indeterminacy. DSE is equal to 36 minus 6 is equal to 30. Then find out the degree of static internal indeterminacy using this expression. DSI is equal to 6 into C, where C is the number of chords required to make the structure open configuration. So here 2 chords required to make the structure open configuration. So this is one chord and this is the second chord. So after taking the 2 chords, the structure becomes the open configuration. So here C is equal to 2. Then you can find out what is the degree of static internal indeterminacy. So DSI is equal to 6 into 2 is equal to 12. So here you know DSE is equal to 30 and DSI is equal to 12. So what is the degree of static indeterminacy? DS is equal to DSE plus DSI, that is equal to 30 plus 12 is equal to 42. Here also you got the same result 42. Then coming to the third example, determine the degree of static indeterminacy of the space frame. Here this is 2 base and 2 storied frame. Here these are the supports, and all the supports are fixed support, and at each fixed support there are 6 reaction components in the case of space structure. So the total number of reaction components are equal to 6 into 6, that is equal to 36. Then count the number of members. So here the number of members are equal to 1, 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. The number of members are equal to 26. The number of members are equal to 26. Then count the number of joints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The number of joints are equal to 18. Then put the value of M, R and J value in this expression. The degree of static indeterminacy of rigid jointed space frame ds is equal to 6m plus r minus 6j. Here you put the value of M, R and J. Then after substituting the value of M, R, J, so ds is equal to 6m plus r minus 6j is equal to 6 into 26 plus 36 minus 6 into 18 is equal to 156 plus 36 minus 108, that is equal to 84. So the degree of static indeterminacy of this space frame is 84. Then the degree of static indeterminacy of this frame also you can determine using the alternative approach. So in this approach you have to find out the degree of static external indeterminacy and degree of static internal indeterminacy. The degree of static external indeterminacy can be found out from this equation, ds is equal to r minus 6. So here you have to find out the number of reaction components. So here the total number of reaction components are equal to 36. So dsc is equal to 36 minus 6 is equal to 30. Then find out the degree of static internal indeterminacy. dsi is equal to 6 into c, where c is the number of chords required to make the structure open configuration. So here how many chords are required to make the structure open configuration? So here you see, so here this is the first chord, so this becomes the open, and here this is the second chord, this becomes the open, this is the third chord, this becomes the open, and here this is the fourth chord, this becomes the open. Then for this closed rectangle, so this is the fifth chord, so this become open, and for this rectangle this is the sixth chord, this become open. Then for this rectangle this is the seventh chord, so this become open, and for this, so this is the chord, so this become open, and for this rectangle this is the chord, so this become the open, ninth chord. So here 9 number of chords required to make the structure open configuration. So after taking the 9 chords, so the structure become the open configuration. So C is equal to 9. So DSI is equal to 6 into 9, that is equal to 54. Then you can find out the DS, the degree of static indeterminacy, that is equal to the degree of static external indeterminacy and the degree of static internal indeterminacy. The degree of static external indeterminacy is equal to 30 and the degree of static internal indeterminacy is equal to 54. 30 plus 54 is equal to 84. Here also you got 84. Then coming to the next example. So this is the space frame, and here you have to find out the degree of static indeterminacy. So here there are 2 supports, so both the supports are fixed support. So at each fixed support, in the case of space frame, there are 6 reaction components. So the total number of reaction components are equal to 6 into 2, that is equal to 12. Then count the number of members. So here the number of members are equal to 1, 2, 3, 4, 5, 6. Number of members are equal to 6. And then count the number of joints. the number of joints are equal to 1, 2, 3, 4, 5, 6. Number of joints are equal to 6. Then after knowing the M, R and J, then you can find out what is the degree of static indeterminacy of rigid jointed space frame by using this expression. So ds is equal to 6m plus r minus 6j. Then put the value of m, r, j here. So ds is equal to 6 into 6 plus 12 minus 6 into 6 is equal to 36 plus 12 minus 36, that is equal to 12. So this is the degree of static indeterminacy of this space frame. And also you can find out using the alternative approach. Here you have to find out the degree of static external indeterminacy and degree of static internal indeterminacy. So the degree of static external indeterminacy can be found out using this expression ds is equal to r minus 6, where r is the number of reaction components. So here the total number of reaction components are equal to 12, because at each support there are 6 reaction components. So here there are 2 supports, so the total number of reaction components are equal to 12. Then you can find out the degree of static external indeterminacy is equal to 12 minus 6 is equal to 6. Then find out the degree of static internal indeterminacy. dsi is equal to 6 into c, where c is the number of cuts required to make the structure open configuration. Here only one cut is required to make the structure open configuration. So after cutting this side, so the structure becomes the open configuration. So here the c is equal to 1. Then you can find out dsi. dsi is equal to 6 into 1, that is equal to 6. Then after knowing dsc and dsi, you can find out the degree of static indeterminacy. So ds is equal to dsc plus dsi, that is equal to 6 plus 6 is equal to 12. Here also you got the same result, 12. So the degree of static indeterminacy of this space frame is correct. Now you are clear what is static indeterminacy and what is rigid jointed space frame, and how to determine the static indeterminacy of rigid jointed space frame by 2 approaches.